In lesson 10, we are going to think about multiples to find equivalent fractions. So we have a couple of math vocabulary words that we use, multiples being when you count by the same number, and that's how much you're adding to the number each time you count. So for example, a multiple of 5 could be 10, 15, 20, 25, 30, 35, 40, 45, 50, and so on. A multiple of 10 would be 10, 20, 30, 40, 50, 60. So you're counting by that number, and that's what a multiple is. So just real quick, the lesson 10, what you notice, what do you wonder? This you could say, I noticed that there are different denominators and numbers on the bottom. You could say, I notice all of the fractions are either thirds or sixths. You could wonder why there's an equal sign in between the two of them. So it's kind of open-ended. It's just what things you notice and wonder on that page. Okay. This is where it got a little tricky for us, because now there's two different ways of trying to solve an equivalent fraction and trying to figure out if it is equivalent. So Elena, what she did is she multiplied the top and the bottom by the same number in each example. So for example, she took the 1/5 and she multiplied the top by 2 and the bottom by 2. So the question that we came up with is, why is she multiplying by 2 on the top and the bottom? Well, if you remember, let me see, I'm trying to get my pen up here. Oh, it's a little slow. There we go. So if you have a fraction with the same numerator and denominator, that is the same as having one whole piece. So the reason she's doing it on the top and the bottom is because as we cut the number of pieces you have into more pieces, you need to cut the whole fraction into more pieces. So if I had the 1/5, let me draw 1/5. It's not going to be perfect. Apologize. Tools are only as good as they're easy to move around. Okay, so let's say this is fifths. So this is my 1/5. But now let's say we had 10 people that were coming and we needed to make sure we had enough for everybody. So unfortunately, we can't go to the store and get more. So we're going to have to break it into more pieces. So notice I'm cutting even the one that I gave you. Let's say I promised that you would have that chunk of the cake. And I'm cutting all my fifths into another piece. So when this is done, we should have 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. And notice if I still had that chunk of the cake or the candy bar or whatever I'm cutting, that one piece was cut into 2 pieces, but you're still getting those 2 pieces. So that's how 2/10 is still equivalent. Let's say we wanted to make the 1/5 fraction into 15ths. Then that means we'd have to cut every one of those fifths that we had into 3 parts. So we're making more pieces, but they're smaller pieces. So again, if I had 1/5, it's this little piece right here. And then I have to cut it into more pieces. So we're going to cut each one into 3 pieces. Oh boy, wish me luck on this. 1, 2, 3, 4, 6. Here's 9. Gonna pretend those are equal pieces there. Okay, so this now makes it that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces. But again, this is 3 pieces because it was 1/5, but then we cut the each fifth piece into 3 pieces more. So we have really tiny pieces, but we have more pieces. Okay, so if you were to continue doing it that way, these fractions would be the equivalent fractions because you're cutting the fraction into more pieces. So once you kind of look at that, you're going to come down here and it says, how are Elena's questions related to Andre's number lines? So how is what she's doing up here for math similar to what Andre's doing down here? Because look, he has 1/5, 2/10, 3/15, and 4/20. Notice this one only has 5 spaces in between. 1, right here, this is 1, this is 2, this is 3, this is 4, and this is 5. So there's 5 spaces. But then when we get down here, it's still lined up. But instead of having 1 big open space, we have 2 spaces there. So they cut it into more pieces, which makes it tenths. Then this one, if we look at this one, it's lined up to the other ones. Numerators larger on the top. That one's a 1, that's a 2, that's a 3. And the 5s are going by multiples of 5. 5, 10, 15. If we were to do it Elena's way up here, it's similar to what she did, right? She multiplied by 2, then she multiplied by 3, she multiplied by 4, and she's getting the same answers as Andre is. So that is another way to do it. However, what we're going to find is using number lines is a helpful tool, but it's not the most efficient way to do equivalent fractions. This is going to take us a long time to do it this way. What we're hoping to shift towards is doing it with multiplication. All right. So, how might Elena find other fractions that are equivalent to 1/5? So what you need to do on this part is you need to do 1/5 and multiply it by a number that you haven't used. So you could do 6, you could do... Okay, sorry about that. We had an interruption, so I had to pause the video. So, anyways, so we could look at these number lines and we could use them to help us find equivalent fractions also. But like I said, it's a little time consuming, so we're trying to find a little bit more of an efficient way. So we were down here and we were talking about how Elena might find other fractions that are equivalent to 1/5. So you could do the multiplication. Like I said, you could do times 6 or times 7, times 8, times 9. She already did 10, 11, 12, 100. So you would try to find a couple of other ways that you could find equivalent fractions. So let me get my pen down here. So if I was to do 1/5, let's see. Oh, goodness. What's going on here? If I was to do 1/5, I could do, let's try times 11. Let's do 11. So I would multiply the top by 11 and the bottom by 11. I can get my pen to work here. Okay, so I would multiply across. 11 times 1 equals 11. And 5 times 11 equals 55. So I'd have 11 55ths. Okay. So that's one way. Hang on a second. Screen's getting smaller for some reason. There we go. So that's how Elena might find some other ways. Okay, let's go on to our next paper in lesson 10. So we're taking what we did on our other page, and now we're looking at Elena's strategy and using her strategy to figure out whether two fractions are equivalent. So we have these two fractions here. We have 5/2. Don't let the 5 scare you. It's a higher number on top because that means we have more than one whole. And 10/8 if it's equivalent together. And same thing, it's a higher number on the top. So we just got to figure out if those are equivalent fractions. So let me pull my pen. Okay. So 5/2. What would it take for us to get to 8? We're thinking about our multiples. What would I multiply, or how many counts would it take for me to get from 2 to 8? Well, I know one of my factors of 8 is 2. When I multiply 4 by 2, I get 8. Now, because equivalent fractions, whatever you do to the top, you do to the bottom, I would have to multiply the top by 4 also. So I'm noticing 5 times 4 equals 20, that these are not equivalent fractions. Because if I was to cut the 5 halves into more pieces so that I had 8s, I would have 20 pieces, not 10. So this one is not equivalent. Nope. Okay, let's try the same strategy, but with 2 6 and 4 12s. Okay, what is it going to take for me to get my 6 into 12ths? Well, again, thinking about my multiples and thinking about my factors, I know I can get 6 to 12 by multiplying it by 2. So that is 12 on the bottom now. And I know I can get my 2 to a 4 by also multiplying by 2. So that one is an equivalent fraction. Okay. So we already did this part. We already wrote our equation. Our equation is what we're doing for multiplication to get to that number. So that one is equivalent. So now we're going to get into a little bit more. Let me see if I can scooch it down a little bit here so you can see the full page. Sometimes I can move it. Sometimes it doesn't want to move. Oh, come on, computer. There we go. All right, so we have 3 rows, it looks like. Maybe. Oops. Sorry, my computer's been very laggy today. I click on something and it takes a while before it will start to focus again. Scroll out. It's not making a huge difference here. Hang on. I apologize for technical difficulties. Just trying to make it so I can see the whole page. And it doesn't want to do that. Oh, whoop. Oh, so sorry. Exit drawing. Maybe it'll come back to me. There we go, finally. All right, so here are all these fractions. They want to know which fractions in this list are equivalent to 3/4. So there's a couple of different ways to go about it. The way that we did this in class is we took 3/4 and we made it as many equivalent fractions as we could. So we took 3/4 and we multiplied it by 2 on the top and 2 on the bottom. And then we multiplied it across and we knew that it was 6/8. Well, hey, there's one that's right here. All right, looking at 3/4, is there anything we can multiply 4 by to get to 10? No, there's not. 10 is not a multiple of 4, so that one's not an option. All right, what about, is there any number we can multiply 4 by to get to 15? There's not, so that's not an option. Is there any number we can multiply 4 by to get to 10, to get to 40? Yeah, there is. 10 times 4, right? So whatever we do to the bottom, we got to do to the top and vice versa. Okay, yep, so 30/40 is. So you would go through this process and you would keep on going until you figure out which ones are equivalent, which ones aren't. All right, I'm going to stop the video for this lesson and I will have another one for lesson 11 in just a moment.